Very powerful concept that we're using in this term and right about now is something called the intermediate value theorem. And now I know at first look it's going to look like oh yeah, duh, but it's very powerful if we start to learn how to incorporate its applications down the road. And basically what the intermediate value theorem tells us that between any 2 points where one is negative and one is positive, there exists a place that crosses the x-axis. So if I have a negative value here and a positive value here, at some point in time, it will cross the x-axis at. So let's look at that right now, and let's look at this particular function to see what that looks like. So let's find out, is there a 0 between the points 2 and 3? So I want to evaluate this at f of 2 and evaluate it at f of 3, because one of the concepts we're trying to do is locate and determine, are there zeros? And where are they at to the best of our idea? So how does the intermediate value theorem help us with that? Well, let's evaluate this at 2. It's a number that I've already produced to show you what's going to happen here. So 2 cubed is 8 minus 4 minus 5 produces a negative 1. So f of 2 is negative 1. And let's look at 3. 3 times 3 times 3 is what, 27? Minus 6 minus 5, and that produces a 16. Produces a 16. So that tells me then that I have at some point, and this graph looks fairly similar. Let's say this is it. Now let's do another graph. At the point 2, I have a value of negative 1. At the point 3, I have a value of 16. So that tells me that somewhere between 2 and 3, I have a 0. I don't know exactly where that 0 is at, but I know that there's 1 there. And that's the power of using the intermediate value theorem as we continue to try to locate zeros and graph some complex polynomial equations.